Hello students, today is lecture 9 of periodic properties. Today we will discuss about periodic trends in atomic volume, typical elements, bridge elements and diagonal relationship. Atomic volume. Atomic volume is the volume occupied by 1 mole of an element under standard conditions. The atomic volume can be calculated by using atomic weight and the density. So the formula is atomic volume is equals to atomic weight upon density. As we are calculating for 1 mole of element, then it is also known as molar volume. If we are talking about the trends of atomic volume in a group, usually atomic volume increases from top to bottom. That means when we go down in a group, the atomic volume increases. This is because increase in number of shells. As we go down, the number of shells increases. Like in first period it is 1, second it is 2, in third period it is 3. So obviously when the number of shells increases, the volume also increases. If we are talking for a period, so when we move forward, that means from the left to right, the atomic volume initially decreases for some elements, and then after reaching a minimum value, it again starts increasing. Here you can see the trend in this graph. It shows that, like in case of lithium, it is initially after lithium it starts decreasing. Then it again increases. Then after sodium it again decreases, then increases. So from this graph it is clear that in case of atomic volume, if we are talking for a period, what happened? First it decreases, then increases, then again increases. There are two factors for this. The first factor is atomic radii decreases due to increase of nuclear charge. That means in a group, when we move forward from left to right, the nuclear charge increases, and due to increase in nuclear charge, it attracts more electrons towards the center of the atom, due to which the atomic size shrinks, and due to this shrinkage, the atomic volume also decreases. Another factor is the number of valency electrons increases in a period. That means in a period, as we know that number of shell is always same. Like if we are talking about second period, the number of shell is second from left to right. But what happened? The number of valence electron increases from 1 to 8. So as the more and more electron enters into particular shell, obviously they require more and more space, due to which the volume increases. Both phenomena happen in a group. Nuclear charge also increases and the valency electron also increases. When nuclear charge increases, it favors decrease in size. When valency electron increases, it favors increase in size. So what happened in a group? Usually, as we know that these two factors oppose each other. So the effect of first factor, that means increase in nuclear charge, is more on the left hand side, which facilitate the decrease in size. Whereas when we go on the right hand side, the second factor dominates, because the number of electron increases in valence shell. So due to this, initially the size decreases in left side, then after attaining a minimum value, again it starts increasing. because the second factor is dominant on the right side. Typical elements. All the elements which are present in second and third periods are called typical elements. For example, lithium and sodium are typical elements of first group. That means in a first group, these lithium and sodium are present in second and third period. So these two are typical element of first group. Similarly, for second group, beryllium is present in second period, magnesium is present in third period. So beryllium and magnesium are typical elements of second group. Also, if after the beryllium, there are boron, carbon, nitrogen, oxygen, fluorine, neon. These all are present in the second period. So these are the typical elements of second period after the beryllium. These are the typical element of third period after the magnesium. So in first period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. These are the typical elements. And same for the third period. Like in third period, the sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. These are the typical elements. So there are total, these are the 12 and these are 4. These all are the typical elements. Now next is the bridge elements. The typical elements of third period are also called bridge elements. Why these are called as bridge element? Because the properties of these bridge elements are somewhat mixed properties of the other elements for which they are act as bridge. Like in period 3, sodium is there. Sodium is present in third period and bridge elements are present in the third period. So first bridge element of third period is sodium. Sodium is having a combined property or a mixed properties of potassium and copper. These two are present in 1A and 1B group. So sodium is known as the bridge element. Similarly, in third period, the second is magnesium. Magnesium also acts as bridge element because it is having a mixed property of calcium and zinc. Again, these two are present in different 1A and 1B group. So the bridge elements are those elements which are having a mixed properties of some different elements. Next is diagonal relationship. A diagonal relationship is said to exist between certain parts of diagonally adjacent elements in the second and third period. So, if we are talking about the bridge element, diagonal relationship and typical element, the second and third period is very important. Clear? So, the diagonal relationship exists in second and third period of the periodic table. The first three members of second period, that is lithium, beryllium and boron. Here, this one is the second period and first, second and third elements are lithium, beryllium and boron. So these are having some similarities with the members of their own group, but show like always in a group the properties are similar. So lithium shows similarities with group 1, beryllium shows similarity with group 2, boron shows similarity with group 13, but apart from these they also show similarity with their diagonal members. Diagonal members, that magnesium is diagonal to the lithium. So lithium and magnesium are having some similar properties. Then beryllium is present diagonally to aluminium. So these two are having some diagonal relationship, and same for the boron and silicon. So these are the three pairs of elements which shows the diagonal relationship, and diagonally in this diagonal relationship, both the elements which are present diagonally show some similarities in their physical and chemical properties. This is all for today. I hope you enjoyed the lecture. Thank you.